Welcome back to math class. Today we're going to be talking about linear and nonlinear functions. You guys are familiar with linear functions, but just a refresher, hopefully you remember, a linear function is a function that makes a line. So when we graph it on our coordinate plane, linear functions make a line. You guys remember all that stuff we did with slope, y equals mx plus b. That's our standard form of linear equations. Today, we're going to be talking about nonlinear functions. A nonlinear function is a function that's not a line. So they can look like this, nice little curve. They could look like this, have multiple curves. They could look like just like that, our exponential functions. Basically, it's any graph that's not a line. A nonlinear function is any graph that's not a line. Now you remember our standard form of an equation for a linear function looks like this: y equals mx plus b. If you can't rewrite an equation to be in the form y equals mx plus b, then it's not a linear function. All linear functions can be rewritten so they look like y equals mx plus b. Even if b is 0, even if m is 0, they can be rewritten to look exactly like this. Now an example of a linear equation, something that could be rewritten as a linear equation, like what if I had 3x plus y equals 2? Now right off the bat that doesn't fit this form, but I could rewrite it, right? I could say minus 3x from this side, minus 3x from this side, and I get y equals negative 3x plus 2. So this is a linear equation because I could rewrite it and it still fits into this form. But what if instead I had y equals 2 raised to the x power plus x squared? I know, that looks crazy, but I can't rewrite that one to fit this form because I have exponents in there, and our linear equation can't have any exponents in there and it still make a line. So the first thing you're going to have to do on your homework today is figure out whether or not something's a linear equation or if it's a nonlinear equation. If you get to something that looks like this and you know that you can't rewrite it like this, then we're going to call it a nonlinear function. This one is nonlinear. Now again, trying to determine whether something's linear or nonlinear, you remember if I have a table of values, I know that it's linear if they increase at a constant rate. So for example, if I had my x and my y values in a table, and my x values are like 1, 2, 3, and my y values are like -5, -20, -45. And I'm going to look through this table and I'm going to go between 1 and 2, I'm adding 1. Between 2 and 3, I'm adding 1. So that is a constant rate of change. Between -5 and -20, I am subtracting 15, right? And from 20 to -45, I'm subtracting 25. Okay, so that is not a constant change. Now because this is the same rate and this one is not the same rate, that means my x and my y aren't changing at a constant rate. So this is a nonlinear function. This is a table of points that would form a nonlinear function. Now if I had a table that looked like this, x and y, and my x's were like 3, 6, 9, and my y's were like 10, 14, 18. Now from 3 to 6, I have plus 3. From 3 to 9, I have plus 3. So that is a constant rate, so that's good. Now from 10 to 14, I have plus 4. Plus 14 to 18, I have plus 4. So this side is also a constant rate of change. So since both sides are increased by a constant rate, then I say yes, this is a linear function. Okay, hopefully you guys see how to tell the difference. If you're given an equation, you can tell whether it's linear or nonlinear, because linear always fits in this form. If you're given a table, you can tell whether it's linear or nonlinear, because linear functions increase at the same rate for both the x and the y, both of them. Nonlinear functions, they don't. They can for one, but they won't for both.